All right, so we're going to start off today by talking about GCD and LCM. So I'm sure some of you guys already know what that is, but the formal definition is for GCD. We'll say the formal definition is, let's say we have integers a and b, and then let the GCD of a and b equal g. So what this means is that g has to satisfy three conditions. So number one, g has to divide a. Number two, g has to divide b. And number three, for all integers c such that c divides a and c divides b, we have that c is less than or equal to g. So what this means is for all integers that are divisible by both a and b, g has to be the greatest one among all of them. And LCM follows a similar pattern or similar definition. So if we have the LCM of a and b equal to L, then what that means is condition number one, a has to divide into L. Condition two, b also has to divide into L. And condition three is for all other integers c such that, for all c such that a divides c and b divides c, we have L has to be less than or equal to c. So for all the other integers that are multiples of a and b, we have that the least common multiple has to be less than all of them. So that's pretty self-explanatory. Let me show you guys how to get the LCM and the GCD of two integers with a quick method. So let's just say we're trying to find the GCD and LCM of 1008 and 196. So it's not very easy to just like think of it. So we'll do this. We have 1008 and 196. We'll go ahead and think of what number divides. This is like similar to the prime factorization method that I showed yesterday. I mean, not yesterday, last week. So what number divides both of them? We can go small. Obviously 2 will divide both of them because they're both even. And then we get 504 and 98. That's what happens when we divide 2 by both of them. And then 2 can divide again, so we get 252 and 49. And then now, it might not be completely obvious, but 7 will divide both of them. And we get 36 and 7. So based off of this, we can say that, we can say that the GCD is equal to this, so 2 squared times 7, and the LCM is equal to all of this. So 2 squared times 7 times 36 times 7. And an important thing to know is that when you multiply the two numbers, so we have AB, that would be equal to the GCD of AB times the LCM of AB. So that's pretty important as well. Okay, so now that we understand the basics, we're not going to move on to problems yet, but I want to discuss something that's also pretty important. It's called the Euclidean algorithm. So the Euclidean algorithm basically states that when we have the GCD of two numbers a and b, then this also equals the GCD of b and r, where r is the remainder when a divides b, assuming that b is smaller. So let's take a look at the example that we did earlier, where when we found the GCD of 1008 and 196. So we can write 1008 is equal to 196 times 5 plus 28. So this is our b, this is our a, and this is our r. Oh, sorry, this should be times, not plus. Okay. And then it says that the GCD of a and b is equal to the GCD of b and r. So we can move this over here since that's b. 196 equals r times, 28 times 7 plus 0. So this is the new a, this is the new b, and this is the new r. So when we have r is equal to 0, then we know that our GCD is going to be the b over here. So that's going to be the GCD of 1008 and 196, it would be 28, just like we solved in the previous one. Just for another example of Euclidean algorithm, because I know it can be kind of confusing, if we do, let's say we want to find the GCD of 1015, and 147 using the Euclidean algorithm. Then we can do 1015 equals 147 times 6 plus 133. So we have A, B, and R here. And notice that this number right here doesn't matter at all. So, and then we can go and do 147 equals 133 times 1 plus 14, because we changed this over here and this over here. And now we do the same thing. 133 equals 14 times 9 plus 7. Then we do the same thing again. 14 equals 7 times 2 plus 0. And so once we get a remainder of 0, we know that the GCD will just be this number. So the GCD will be 7. So that's how you do Euclidean algorithm, basically. Okay, one more theory thing that I want to cover before problems is something called Bosons Identity. Although this doesn't show up extremely often, but it's still important to know it. Basically what it states is that when we have two integers a and b, right, and we try to find the value of ax plus by, where x and y are any integers, can be positive or negative, doesn't matter. So basically we're taking any combination of a and b, adding them together, or subtracting, doesn't matter. The minimum number that you can get out of this is equal to the GCD. So I'll show you a problem that involves Bosons identity later, and you'll understand what it means. So the minimum of that equals the GCD. Oh, for the Euclidean, I guess I can explain it again. So let's say, so for Euclidean algorithm, basically you take the greater number and then you divide it by the smaller number and find the remainder. So here we have 1015 equals 147 times 6 and then equals plus the remainder. And then now we take what we had for b, and then we, instead of making it b, we in turn make it a. So 147 over here. So 147 over here was 147 over here, and 133 here was 133 there. And then similarly, we put this 133 over here and take the 14 here and put it here. Basically, we just continue to divide, and then divide the what's here by the remainder. And then until we get a remainder of 0. And then once we get a remainder of 0, we know that the GCD is going to be the divided thing from basically the previous remainder. Okay, now I'm going to show you guys a problem that involves Bosons identity. So go ahead and read that. Oh, and also all of these problems can be found on the class website where Rich posted a handout. It has all the problems in there and also space for you to take notes. Okay, so this problem basically says that you need to, basically the idea of this problem is that you're trying to somehow exchange 300 and 390 so that you get the minimum possible value. So what this is essentially saying is you're trying to find the minimum value of 300x plus 390y, because if you if farmer A gives farmer B 300, and then farmer B gives farmer A 390, then the net would just be 300 times 1 plus 390 times -1, and then that would give you 90. Basically, you're just trying to find combinations of these two numbers added and subtracted so that we have the minimum possible debt that can be resolved. So as I said earlier, Bosons identity states that the minimum possible number that you can get for this result is the GCD of this. Oh, sorry, I don't know why I said 390. I meant 210. Sorry. All right, so we're trying to find the GCD of 300 and 210. And then it's pretty easy to tell that the GCD is just going to be 30. So that's the answer for this one. Does anyone have any questions about how I got that? All right, so if you're trying to exchange possible, like for example, a $390 debt could be paid with 2 pigs, 1 goat received in change. So that just means that farmer A can give farmer B 600, and then the farmer B can give farmer A 210, and this way you can resolve a $390 debt. Basically, it's telling you that you're trying to like find the smallest possible combination of 300 and 210 possible. So, and by Bosons identity, the smallest possible combination sum is just going to be the GCD, which is 30. Okay, I'm going to move on to the next question. This one's a bit longer, so go ahead and read it. Okay, basically what this question is saying is that these 10 horses, they each take a certain amount of time to finish running a lap. And it's trying to ask you for the minimum amount of time possible such that 5 horses finish at the same time. So after a certain amount of time, the minimum amount of time that it takes for 5 horses to be done. So we're trying to find basically the LCM of any 5 of these such that the LCM is minimized. I'll show you what I mean. So the first horse can finish a lap in 1 minute, and then the second one can finish a lap in 2 minutes, then 3, 4, 5, what is that? 4, 5, 6, 7, 8, 9, and 10. So as I said in the last time, we want to like prime factorize whenever we can. So in the numbers that are not already prime, 4 can be prime factorized as 2 squared, 6 can be rewritten as 2 times 3, 8 can be rewritten as 2 cubed, 9 can be rewritten as 3 squared, and then 10 can be rewritten as 2 times 5. So we're trying to find some combination. Let's find, so T has to have 5 of these numbers as divisors, at least 5. And we're trying to minimize the value of T. So that means we want to find as many 5 of these that can involve, like as many of these, we're trying to find a number such that 5 of these will divide it. So let's look at this number right here. If we look at 2 times 3, 2 times 3 already has 4 divisors. The divisors are 1, 2, 3, and 6. So now we just need to multiply this by something, so that we get a 5th divisor in. So if we look at this number right here, obviously 2 squared is not divisible by 2 times 3. But if we multiply it by another 2, then it will be divisible. And so that means the divisors of this will include 1, 2, 3, 6, and 4, and 12. But we don't care about 12 because all we're worrying about is the numbers in here. So that means that 12 is going to be the least possible number that is a multiple of 5 of these numbers. 5 of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And for this problem, you want to be careful because a lot of the times people look at 8 and think we should include 8. But if you look further, if you think about it some more, we can use 12, and 12 would also work. So that means don't include 8 into the number. Okay, does that make sense, guys? All right, we're going to move on to the next topic, which is divisibility rules. Okay, this one, we're going to include a bunch of numbers. So we're going to talk about the divisibility of all the numbers from 2 up to 11, except for 7, because 7 is weird. And you can find all of this on the packet that is posted on the website. So let's start off by 2. The divisibility rule of 2 is pretty easy. It just has to be even. And then the divisibility rule of 3 has to be such that the sum of digits is divisible by 3. So let me show you guys why. So if we have a number that's like 10, if we have a number that's a 2-digit number, we'll call it AB, or let's do a 3-digit number, because why not? So let's say I have the number ABC, right? we can rewrite this as 100A plus 10B plus C. So think about it. We can also rewrite this as 99A plus 9B plus C, and then plus A and plus B, because 99A plus A is 100A, 9B plus B is 10B. So if we look at this, then we can tell that 99A and 9B are both going to be divisible by 3, so we don't have to worry about those terms. So the only thing that's left is C plus A plus B, which is the sum of the digits. So those are the only, so you just need to find the sum of the digits to determine if a number is divisible by 3. All right, so the next one is 4. So if 4 means that, the rule for 4 is that you look at the last 2 digits and see if it's divisible by 4. So if we have 1, 2, 3, 6, then we don't care about this part, all we care about this, and we see that 36 is divisible by 4, so that means 1, 2, 3, 6 is divisible by 4. And the reason why is because if we have, let's say we have a number A, B, C, D, right? We can rewrite this as 1000A plus 100B plus 10C plus D. And if you look at it, 100A and 100B, sorry, 1000A and 1000B are 100% going to be divisible by 4, because 1000 is divisible by 4 and 100 is also divisible by 4. So the only part of ABCD that we care about is 10C plus D, which is also just the last 2 digits in the number form. Okay, so then for 5, the divisibility rule is pretty obvious. Just has to be last digit has to equal 0 or 5. That's pretty self-explanatory. I'm not going to go over why. And then for 6, we actually look at it like this way. So we know that 6 equals 2 times 3. So we already know the divisibility rule for 2, and we also know the divisibility rule for 3. So to find the divisibility rule for 6, all we have to do is make sure the number is even and also divisible by 3. Which also means that the number has to be even and sum of digits divisible by 3. So for example, if we look at the number, let's say 216. So 216 is even, and also the sum is going to be 9, so it's also divisible by 3. So therefore 216 is divisible by, I don't know what that was. 216 is divisible by 6. All right, 7, the divisibility trick for 7 is really weird, and it's really not worth knowing. So for 7's, just memorize, or not, just divide it out. And then for 8, it's also similar to 4, but instead now you look at the last 3 digits. If we have A, B, C, D, you look at the last 3 digits and see if this number, B, C, D, is divisible by 8. And if it is, then the whole thing is divisible by 8. And the reasoning is similar, but basically you have, let's say you have 1000, for this, let's just expand this, 1000A plus 100B plus 10C plus D. And we know that 1008 will have to be divisible by 8 because 1000 is divisible by 8. So we don't have to look at this term, which just means that the rest of it is just the number BCD. And so this number is the only number, this part is the only part that determines divisibility by 8. And then we have divisibility by 9. 9 is similar to 3, it's just the sum of digits. And it's the same reasoning as sum of digits is divisible by 9. And it's the exact same reasoning as 3, so yeah, I'm not going to go over it. And then 10 is obvious, just last digit is equal to 0. And then 11 is a little bit more complicated. So basically, if we have something to be divisible by 11, let's say I have the number A, B, C, D, E, F, G, because, yeah. So we start from the units digit and we alternate. So we have G, E, C, and A, and we add them together. G plus C plus E, oh, sorry, A plus C plus E plus G. And then we do the other alternating ones. So F, D, and B. So B plus D plus F. So you find this sum right here, and you also find this sum right here. And if the difference of these sums is a multiple of 11, then that means the number is divisible by 11. All right, so Now we can go in and start working on some problems. Okay, so go ahead and read that problem. All right, so it's basically saying that there's a number 1, 2, 3, A, B, C, and it's divisible by 990. So let's go ahead and factor out 990 into simpler numbers that we know the divisibility rules for. So 990 is going to be equal to 9 times 10 times 11. Well, we know that for 10, C has to be 0. So our number now becomes 1, 2, 3, A, B, 0. So let's think about the divisibility rule for 9 real quick. So we know that 1 plus 2 plus 3 plus A plus B has to be a multiple of 9. So 6 plus A plus B is going to be equal to a multiple of 9, so 9m. And then if we're going to look at the divisibility for 11, we know that 0 plus A plus 2, so 2 plus A, minus 1 plus 3 plus B, so minus 4 minus B is going to be equal to some multiple of 11, so 11k. And now if we simplify this, we get A plus B equals 9m minus 6, and then A minus B equals 11k plus 2. We know that m and k can be, wait, did I do that correctly? Let me check. Oh, sorry, wait, I think I did something wrong, wait. Oh, no, I didn't, don't worry. All right, so we know that 2a, if we add these two equations, we get 2a equals 9m plus 11k minus 4. So let's just go and look through these values for m and k. So if we have, let's just say we want to make sure that we get 9m plus 11k minus 4 is even, right? So let's say we have what's a possible way that we can make this into okay, so basically after we experiment around with the values of m and k, you get that 2a is equal to 14. So the best way for that to work is if we just do 2 times 9 minus 4. So we get m is equal to 2, and then k is equal to 0, minus 4, and then we get 14. Basically, to get m equals 2 and k equals 0, all you have to do is just plug in numbers for m and k and make sure that it works. And when we find out that when m equals 2 and k equals 0, then it works. So we get a equals 7. And then if we plug it into the earlier one, we get b equals 5. So I'm not going to actually plug it in because I trust that you guys know how to do that. So then we have c obviously equals 0 because from earlier. So we have 7 plus 5 plus 0 equals 12. So that's our answer. Does anyone have any questions? Oh, if you want to see the question, I can show you now, but for later problems, just go to the website, and then there's to go to the class resources section, and then just go to week 2 lecture problems, and you can follow along for all the problems I do. Okay, next problem. This one's not like exactly a very like direct application of divisibility rules, but also includes it. So I felt that we should go over this problem. Okay, so go ahead and read it. Okay, so let's have some variables. So C, let's make it the total amount of coffee that all of the family members drink. And then make M equal to be the total milk that everyone drinks. Okay, so we know that, and let's let N equal to equal the number of people in her family. So now we can write a few expressions. We know that total coffee plus total milk is going to be 8 times n, because each person in her family drinks 8 grams or 8 ounces. And then the second equation that we can write is 1/6 of C plus 1/4 of M equals 8, because that's just what Anne really drinks. She drinks 1/6 of the total coffee and 1/4 of the total milk. All right, so we can go ahead and let's do some manipulating with these equations. So first we want to make the second one similar to look like the first one. So in order to do that, all we have to do is just multiply both sides by n. So n over here and n over there. And now we can equate these two equations. So C plus M equals 1/6 n C plus 1/4 n M. And now we can go ahead and like rearrange the equation, and we get 1 minus 1/6 n. Or actually, let me just show you guys all the steps, because I remember I was a bit confused. So C minus 1/6 n C equals, yeah. And then we can pull out the C from from this side, equal, and we pull out the m from this side. All right, so we have this equation right here. But something that you want to notice about this equation is that these two terms both have to be positive. Or they can both be negative, but they're both going to be positive because n over 4 minus 1, if it's negative, then this one will be positive. Okay, you'll understand it, but just make sure you understand that why these two have to be the same sign, because C and M both have to be the same sign because they're both positive. So if we have 1 minus n over 6 to be positive and n over 4 minus 1 to also be positive, we can rewrite this as n over 6 is less than 1, and rewrite this as n over 4 is greater than 1. And then we rewrite these two inequalities, and we get n is less than 6 and n is greater than 4. So obviously, we know that n has to be between 4 and 6, so that means n is equal to 5. So there are 5 people in her family. Does that make sense to you guys? Okay, good. All right, the next problem, I realized that after making the set that I realized that this one would be a lot easier if we, after I discussed mods. So we're just gonna skip over this problem for now. We'll come back after I finish teaching mods. Okay, so let's go over, I'll explain whatever questions they need me to re-explain at the end. Okay, so modular arithmetic basics. Modular arithmetic is basically arithmetic with remainders and integers. So if we have, let's say we have 100 mod 3, that means that we're trying to evaluate the remainder when 100 is divided by 3. Well, obviously this would equal 1. So in this case, 100 would be congruent to 1 mod 3. So besides being congruent to 1, 100 can also be congruent to a variety of different numbers mod 3. So 100 can also be congruent to 97, because both of them have a remainder of 1. They can even both be congruent to -2, because -2 has a remainder of 1 when divided by 3. So basically, let's say you have m, and then even if m will be congruent to m plus, no, sorry, let's not use m, that's a weird. Let's say you have a number n mod m. So n will be congruent to anything, n plus m times any integer, or plus or minus. Because this number right here, after you divide it by m, it's going to give you the same remainder as n. So basically, let's think about, let's say we have 10. 10 mod 10 is going to be congruent to 0, can be congruent to -10, -100, you get the idea. So for modular arithmetic, we can do basically all of the all of the operations in normal math, except for division. Division has a very different set of conditions in modular arithmetic. So let's say we have, obviously 4 is congruent to 6 mod 2, right? Because both of them have the remainder of 0 when divided by 2. We can do anything to these two sides except for divide. So let's multiply, we can multiply both, we can add 1 to both sides, 5 is congruent to 7. We can do anything, but we just can't divide. We can even do exponents, we can do anything that we want. All right, so now let's talk about a problem that is like basic for mods. Well, actually, let me just show y'all the special reason why we can't divide by the same number in modular arithmetic. Well, for division, there's 2 conditions. Number 1, if we have, let's say we have 4 is congruent to 6 mod 2, we can only divide if, we can only divide if we have, let's say we want to divide by 2. If we want to divide 4 and 6 by 2, then we also have to divide the mod by 2. So you have to do 4 divided by 2 is congruent to 6 divided by 2 mod 2 divided by 2. So if we wanted to divide both sides by something else that's not divisible by the mod, then we can't do it. So for example, if we have like 18 is congruent to 36 mod, I don't know, like 6 or something. Even though both of these are divisible by 9, we can't just do this. We can't just do 2 is congruent to 4 mod 6, because that's obviously not true. But instead what we can do is we can divide both sides by 3, and also the mod by 3. So if we have 18 is congruent to 36 mod 6, we can divide everything by 3. So we can get 6 is congruent to 12 mod 2. Or we can divide everything by 6 if we want. So we get 3 is congruent to 6 mod 1. That would also work. But as long as we have, as long as we can divide everything, including the mod, by that number. Okay, yeah, all right. Now we'll move on to modular arithmetic problem 1. So go ahead and read that. Okay, the wording might be a little bit confusing, but basically what we're trying to do is we have natural numbers, we have p divided by p after it divides d, it gives a remainder of r. And then if we do p prime divided by d, it gives a remainder of r prime. So basically, we can rewrite this in modular form because once you start getting into like advanced number theory problems, you always want to try to use mod form because this way it's a lot easier to do computations and everything. So let's go ahead and rewrite this as mod form. So we know that p is congruent to r mod d because the remainder when p, sorry, that looks like d. So the remainder when p is divided by d is equal to r. So these two are going to be congruent mod d. And then similarly, p prime is congruent to r prime mod d as well. So now we can, remember we can do as many operations as we want, except for divide. So let's go ahead and multiply because that's essentially what the problem is asking. It's asking the relationship when you have pp prime and rr prime. After you divide those by d and you want to find the remainder, this one gives r and this one gives r prime. You want to find the relationship between these two. So we're trying to find, so let's go ahead and multiply this. So let's multiply p times p prime and r times r prime. We get pp1 is congruent to rr, sorry, why did I say one? pp prime is congruent to rr prime mod d. So we know that p prime is congruent to rr prime, and p prime is congruent to r mod d, and r prime is congruent to r prime mod d. So that means r and r prime are going to be congruent mod d. Does this make sense? It's just an easy, like, it's just like the introductory problem that to show you how to use operations on modular arithmetic. Does this make sense? Because mods are really important in number theory. They come up on like almost all number theory problems. Well, not all, but like most of the non-divisor ones. Okay, I'll show you guys another problem so that you understand how to use mods in like operations. So this one, it just says that we want to find a cubed plus, well, the minimum a such that a cubed plus 23 is divisible by 24. So again, let's write this in mod notation. So a cubed plus 23 is going to be congruent to 0 mod 24 because the remainder is going to be 0 because it's divisible. So now we can do any operations that we want, right? Wait, if you guys are asking question marks, does that mean you're confused? Because I can like go over whatever you're confused about, but if not, I'll just, like, what part do you not know? Do you want me to re-explain mods? If you want, I can go ahead and re-explain mods. Okay, I'll go ahead and re-explain mods then. Oh, why they were still, what do you mean, why, like this one? Okay, sure, I'll explain this one again. So, let me show you guys the problem again. Okay, so we know that p, after you divide p by d, the remainder is going to be equal to r, right? So we can rewrite this in mod form as p is congruent to r mod d because that r is the remainder when p is divided by d. So that means they're congruent mod d. And then if we have the similar case was p prime divided by d has a remainder of r prime. So we know that p prime is congruent to r prime mod d. So remember that I said that you can, sorry, I need to erase this part because, whoops. Remember how I said earlier that you can do any operations on mods that you want except for divide? Well, we can go ahead and do multiplication. So we have this and we have this, right? We can multiply p and p prime. And over here we can multiply r and r prime. And they'll still be congruent because multiplication is allowed. So then this will just be congruent to each other mod d, right? So then basically the question is saying that you're trying to find the relationship between p prime and r prime mod d because those are the remainders. Because it says p prime divided by d gives a remainder of r, and p and r prime divided by d gives a remainder of r prime. So then we know that in this it's telling you that p prime is congruent to r mod d. And then over here it's telling you that r prime is congruent to r mod d, right? So then we know that p prime is congruent to r. So let's say r is over here, and r prime is going to be here. So that means r is congruent to r prime mod d. And that's the answer because it's just asking you for the relationship between r and r prime. Okay, I'm just going to move on to the next question because at the end I'll try to answer as many questions as I can. All right, so in the middle of this question, we got to a cubed plus 23 is congruent to 0 mod 24. And we can subtract 23 from both sides because subtraction is allowed. a cubed is congruent to negative 23. And remember when I said that negative 23, as long as you add any multiple of 24 to it, it'll be congruent. So let's go ahead and add a multiple of 24. So negative 23 plus 24 will be congruent to 1. So now we know that a cubed is congruent to 1. And that just means that a is going to be congruent to 1 as well, because that's the only way that you can get, because when a is congruent to 1, if we find a cubed, that'll also be congruent to 1. Because you can do multiplication in mods. So now basically we know that now we just know that a is congruent to 1 mod 24. And the reason why no other a works for this is because, well, if we have, let's say we have like negative 1, you cube it, you get negative 1 mod 24. We get anything, and then we cube it, mod 24, it doesn't work. But this is like, to like prove that a is congruent to 1 is the only residue, or the only possible value for this. It actually involves like more than just like, it involves like other theorems, so I'm not going to go into those, but since we know that a cubed is congruent to 1, we can deduce that a is congruent to 1 mod 24. So then the values of a will just be numbers that leave a remainder of 1 when divided by 24. So that'll give you numbers like 1, 25, 49, basically anything that leaves a remainder of 1 when divided by 24. Okay, does that make sense for you guys? Okay, I'm gonna move on to the next question. All right, so this one is supposed to be not extremely hard. Go ahead and read it. It just says, what is the rightmost digit of 3 to the power of 2006? There's like a easier way to do this, and there's like a more theoretical way to do this in which you actually understand why you do it the easy way. So I'm gonna do it the more theoretical way so you guys understand. So if we try to find the rightmost digit of this huge number, we're essentially trying to find the number mod 10, right? Because mod 10 will just give you the remainder, which is the last number. Well, yes, we can do it the easy way, which is the pattern. So 3, 9, 7, 1. We get this pattern because 3 to the power of 1 is 3, 3 cubed is 9, 3 to the power of 3 is 27, which means the last digit is 7, and then 3 to the power of 4 is 81, which means the last digit is 1. And once we have 1, the pattern will just repeat itself, and then we're trying to find the number for 2006. So 2006, the remainder, when it's divided by 4, is congruent to 2. So then we're trying to find the second number in this pattern, so the answer will be 9. But the reason why we can do this is actually not is something that I want to go over. So if you consider the last digit of a number, let's say you have a number AB, right? The last digit of AB is congruent to B mod 10. So using mod 10, we know that 3 is congruent to 3 mod 10, and then 3 squared is congruent to 3 times 3 equals 9 mod 10. And then if we do 3 cubed, we have whatever we have here, 9 times 3 mod equals 27, but is also equal to 7 mod 10. And then 3 to the 4th is 3 cubed times 3 equals 7 times 3 mod 10. So equals congruent to 1 mod 10. But because basically you're finding your pattern here, but it's because you're taking everything mod 10 that you can find your pattern. So through this, we found the reason why we have our pattern, because each one of these we're taking it mod 10, which means that the final answer will just be 2006. 2006 leaves a remainder of 2 and divided by 4, so we'll have 9. Okay, so that's like the end of the problems for today, but there was the other problem that I skipped over, remember this one? Well, yeah, this one, it's much easier to explain when I can use mods. So, yeah, go ahead and read that. Okay, so we know that we have a number, ABCD, 5-digit number, so ABCDE. And then once we divide it by 100, then we get Q, and then the remainder is R. So we know that this is going to be 100Q plus R. So now we want to know how many values of n, which is this number, do there exist such that Q plus R leaves a remainder of 0 mod 11, meaning that it's divisible. Oh, you can't hear me? I'm sorry. All right, so let's look at this right here. So we have, well, we can go ahead and add 99Q plus Q plus R, and this would still be congruent to 0 mod 11. Why? Because this number right here is congruent to 0 mod 11. Because 99 is congruent to 0 mod 11. And 99Q is going to be congruent to 0 mod 11, which means that adding 99Q is essentially just adding 0. So then we get this. So Q plus R, which is what we're trying to find, is congruent to 100Q plus R, which is congruent to 0 mod 11. So doesn't that just mean that since this is equal to n, since this is equal to n, right? That just means that n is congruent to 0 mod 11. And essentially what that means is that n is a multiple of 11. So we know that n is going to be a 5-digit number. So the smallest 5-digit number that's divisible by 11 is, I think it's, 10010. And then the largest one is going to be 9990. And in order to find the number of numbers between, or number of multiples of 11 between these two numbers, you just do like that divided by 11, which gives you 910, I think. And then this one divided by 11, it gives you 9090. So then the number of, so then we just do 9090 minus 910 and plus 1. This is in combinatorics. Rich should teach you this. And then this will give you 8181. So that's your answer. Essentially, the main idea of this problem was that you had to recognize that 99Q is congruent to 0 mod 7. Oh yeah, sure. I'll go over the first part. You know, I'll just like re-explain it since it was kind of like interesting. Anyway, we know that the 5-digit number ABCDE, n, is equal to ABCDE. And so after you divide it by 100, we get 100Q plus R. Or we get Q and then the remainder is R, so we can rewrite this as 100Q plus R. This part makes sense, right? This is just simple algebra. And we know that we want to find Q and R such that Q plus R is a multiple of 11. Because it's a multiple of 11, that means the remainder when you divide it by 11 is going to be 0, which means that it's going to be 0 mod 11. And as I said earlier, we can add 99 to this because let's just consider 99Q real quick. 99Q is congruent to 11 times 9Q, right? And as I said, 11 mod 11, 11 is obviously congruent to 0 mod 11. So this whole thing is just congruent to 0 mod 11. So even if we add 99Q to this, even if we add 99Q to that, it won't change the value of 0 because it is 0. So now we can just add 99Q because it won't change anything, right? 99Q plus Q plus R is congruent to 0. So we have 100Q plus R is congruent to 0. And look, as I said earlier, see, look, 100Q is n. So then we can just replace 100Q with n over here. So n is congruent to 0, mod 11. So the meaning for n being congruent to 0 mod 11 just means that when you divide n by 11, the remainder is 0, which means that n has to be a multiple of 11. And whoops. And the question said that n has to be a 5-digit number, so it's going to be from 11 times 910 up to 9990 times 11. which means there's going to be 8181 numbers for n. All right, so that's all of the problems that I have for today. Let me know if you have a certain question that you want me to go over again. Is there a certain question that you guys want me to review that wasn't like very clear? Oh, the horse one. Okay, cool. I'll go over the horse one. I'm assuming you guys already like know what the question is asking, right? So I'm just gonna start up a new page. All right, so basically what it's saying is there's 10 horses. So each one of these 10 horses can finish a lap. So there's the lap. Oh, whoops. Okay, so here's the lap, right? Horse 1 can finish the lap finishes the lap in 1 minute. Horse 2 finishes it in 2 minutes, etc. And horse 10 finishes it in 10 minutes. That's basically what the question tells you. And then what it's asking is that you want to find a minimum number t. T is a time, such that after this amount of time, there are 5 horses who are at the starting point. So everyone starts at the starting point at time 0, and then it's asking you after how much time, after how much time will it be such that there are 5 horses all here, there are at least 5 horses standing at this starting point again. So let's think, how can a horse be at the starting point again? That just means they've finished a whole number of laps. So it takes horse 1 to finish 1 lap, it takes horse 2 to finish 2 laps, it takes 4, 5, 6, 7, 8, 9, and 10. It takes each horse this amount of time to finish a lap. And we want to find the minimum time such that there are 5 horses who are simultaneously finished a lap. So let's try to find, we're basically trying to find the least possible multiple of 5 of these numbers. So let's look at 6. The number 6, we're trying to construct t, right? So let's construct t, and let's say we have 2 times 3 currently. 2 times 3, we know that horse 6 has finished a lap. Horse 2 has finished a lap. Horse 3 has finished a lap as well. And horse 1 obviously has finished the lap also. But now we only have 4 horses that are at the starting point right now. We need 5. So what is the minimum number? We obviously have to multiply by something else. So what is the minimum number that we can multiply by again so that we can get another one of these horses to also be done with that lap? So obviously if we multiply by 4, if we want horse 4 to also be finished with that lap, all we have to do is multiply by 2, because this way we get 12, and 4 is a divisor of 12. If we're doing 5, then we'll have to multiply the whole thing by 5, 7, whole thing by 7, 8, whole thing by 4, and then 9, have to multiply the whole thing by 3. And for 10, we have to multiply the whole thing by 10, which does not make, or 5, which does not make any sense at all. So the best possible strategy for us to construct this t is if we just multiply by 2, so that horse 1, horse 2, horse 3, horse 4, and horse 6 will all be at the starting point at that time. So that gives you the answer of 12. So the problem originally asked for the sum of the digits of t, so the sum of the digits of t will just be 1 plus 2 equals 3. Does that make more sense? Okay, I'm glad it makes more sense, because yeah, I remember on the real contest that this was, I got this one wrong. So yeah. All right, is there another question that you guys want me to go over? Oh, the milk one? All right, cool. I think we'll have enough time to go over that one. So here is the problem for the milk one. Since you guys already know the question, I'm just going to start up another page. All right, so first, basically what the question is saying is that in the family, there are a number of people, we don't know how many, but there's n. Let's say there are n number of people. total number of people in the family. And then each one of them every morning drinks an 8-ounce mixture of coffee and milk, but we don't know like what the percent of coffee is, what the percent of milk is in each one's mixture. So let's just say C is the total amount of coffee in all of their drinks. And M is the total milk in all of their drinks. And the question also tells us that Angela drinks a total of 8 ounces on that day. So we know that, and each person also drinks 8 ounces, but they told us that Angela's coffee was 1/6 of the total coffee, and then Angela's milk was 1/4 of the total milk. And we also know that Angela drank 8 ounces, so we can write that equation. Another equation that we can write is that the total amount of coffee plus the total amount of milk, since everyone also drinks 8, we can write it as 8n because each person drinks 8 ounces and there are n people. All right, so now we have to do some like diaphont. So we just have to like somehow make the top equation look like the bottom equation because we want to find C and M first. So if we multiply the top equation, we multiply by n, right? Then we can write n over 6c plus n over 4m equals 8n. And 8n is also equal to c plus m, so we can write c plus m over here. So then let's go ahead and rewrite this equation so that the c's are on one side and the m's are on one side. All right, so we can go ahead and say 1 or c minus n over 6c. We're removing this one over here, this one to that side. And then we can say equal to n over 4m minus m. We're just basically moving the m to the other side. This is just simple algebra, so yeah. And then we take out the c, we get 1 minus n over 6 equals m times n over 4 minus 1. So now, now we gotta look. It says that the amount of coffee and milk is non-negative or not zero. So basically it has to be positive. C and M are both positive, which means that 1 minus n over 6 and n over 4 minus 1 have to be the same sign in order for these two to equate. And now we know that n over 6 has got to be less than n over 4, right? So so therefore this has to be positive and this also has to be positive because if this is, let's assume that they're both negative. If they're both negative, then 1 minus n over 6 is negative. Then n over 4 minus 1 has to also be negative. But this doesn't make sense because we have n over 6 is greater than 1. And then over here we've got n over 4 is less than 1. So that doesn't make sense, right? Because n over 6 has got to be less than n over 4. So we know that both of these terms are positive. So if they're both positive, 1 minus n over 6 is greater than 0, and n over 4 minus 1 is also greater than 0. So over here we get n over 6 is less than 1, and over here we get n over 4 is greater than 1. And then if we just multiply both sides by 6, over here we get n is less than 6, and over here we get n is greater than 4. So n is greater than 4, but n is less than 6, so n's got to be 5. So that's the number of people in her household. All right, that's it. That's all I've got for number theory today. Please try to do the homework because it has some really cool problems that I really hope you guys can try. And if you guys have any questions, just email us or text us. Yeah.